Hey everyone, welcome to this explainer. So, have you ever stared at a dying plant and just felt completely helpless? Well, today we're fundamentally changing how you look at your garden. We're focusing entirely on the initial assessment. And by that I mean we're throwing out the guesswork and adopting a real forensic approach to diagnosing plant problems. Instead of just randomly spraying chemicals or, constantly moving pots around and crossing your fingers, you're going to learn how to act as the lead investigator at a botanical crime scene.
Because it always starts with this exact question, doesn't it? Why is my plant dying? I mean, it's literally the single most common, frustrating, and honestly heartbreaking question every gardener, farmer, or houseplant enthusiast asks when they see a plant going downhill. You pour your time, your money, and so much love into your plants, and suddenly, boom, the leaves are curling, the stems look super suspicious, or those flowers you were waiting for simply never show up. You want to blame something, and let's be real, usually our very first instinct is to blame a bug.
Okay, let's dive into this because this quote from the source material absolutely subverts everything we tend to assume. Read that again with me. Insects and pathogens rarely attack healthy plant tissue. This completely shifts the blame, right? Think of it kind of like a weakened immune system. The bugs or the fungi you're seeing, they're often just secondary invaders. They're basically opportunists that show up only after your plant has already been deeply stressed by some underlying environmental factor. So here is the roadmap for our explainer today. We'll start with Step 1, the crime scene. Step 2, identify the victim. Step 3, symptoms versus signs. Step 4, tracking the timeline. And finally, Step 5, the usual suspects. Let's kick things off with Section 1, the crime scene. It's all about understanding the environment. Before we even zoom in on a damaged leaf, we really have to zoom out. In plant pathology, infectious diseases do not just happen by chance. It's like a giant puzzle. For a disease to successfully take hold and spread, the disease triangle must be completely intact. 3 specific conditions literally have to exist at the exact same time. You need a susceptible host plant, an active pathogen, and a favorable environment, like, say, high humidity or super soggy soil. If a pathogen is hanging around but the environment is perfectly dry, no disease. If the environment is soggy but the plant is genetically resistant, again, no disease. All 3 of these must align perfectly. And that brings us to our absolute greatest weapon. As garden investigators, we can actually break this triangle. If you deliberately alter just one of these key factors, you stop the disease right in its tracks. For example, you can choose to plant resistant varieties, which effectively removes the susceptible host. You could practice proper sanitation by disinfecting your clippers and tools, which takes out the pathogen. Or you can just adjust the environmental conditions, like spacing your plants out a bit for better airflow, to totally ruin that favorable environment. Moving right along to Section 2, identify the victim. We need to establish a baseline. In any investigation, those first 48 hours are absolutely crucial. The professional diagnostic protocol insists that you first establish a baseline. Now, the source material offers a pretty stern warning here. You cannot accurately define a problem if you don't actually know the plant's inherent characteristics. You've got to know what normal looks like for that specific species and cultivar before you can ever claim that it looks sick. And this brilliantly illustrates exactly what we mean. Think about inherent genetic traits. A plant might have naturally variegated thyme leaves, or it might be a specific cultivar of hosta that is naturally yellow-green. Now, to the untrained eye, that looks like a severe nutrient deficiency, right? But contrast that with actual indicators of distress, like true chlorosis, which is a real yellowing caused by poor nutrition or overwatering. Knowing the difference is absolutely crucial. It prevents a completely false diagnosis that might lead you to, say, aggressively over-fertilize a perfectly healthy plant. Now for Section 3, symptoms versus signs. Time to gather the physical evidence. All right, now we're transitioning into gathering that physical evidence. And to do this correctly, we have to separate the plant's internal cry for help from the physical footprint left behind by the actual culprit. Consider stunted, twisting leaves. That is a symptom. A symptom is the victim's biological response to the attack. On the flip side, seeing a caterpillar actively chewing away on a leaf, that is a sign. A sign is the fingerprint left behind by the attacker itself. It's the visible physical evidence. And here's the tricky part. You can have symptoms without immediately seeing the signs, which is exactly why we have to be so thorough. Let's rapidly showcase a few common symptoms from our source data so you know exactly what to look for out there. First up is a gall. Look at that massive abnormal swelling on the trunk. It honestly looks like something straight out of a sci-fi movie, doesn't it? But this incredible distortion happens when fungi, bacteria, or insects basically hack the plant's growth hormones and force it to grow this localized mass. Next, we have a symptom known as russeting. Notice how the skin of this fruit has become noticeably discolored, thick, and rough to the touch. This isn't just a simple blemish, it's a very specific symptom that really helps us narrow down exactly what kind of stress the plant is enduring. But wait, here is where we have to be incredibly careful. Think about a shredded, tattered leaf. It looks like a catastrophic insect swarm just came through and feasted, right? Well, a lot of the time, this is actually mechanical damage. Physical, blunt force trauma from extremely high winds, or even just a dramatic, careless pass with a weed whacker, can easily mimic a contagious biological disease, which leads us perfectly into our next investigative tool.
Section 4, tracking the timeline. We're looking at spatial and temporal clues.
So now that we have secured our physical evidence, we have to analyze the scene spatially. Look closely at how the damage is distributed across an area. Living invaders, those are abiotic factors, like fungi or insects, they spread sporadically. They start at a cluster and then sort of hop over to neighboring susceptible hosts. But non-living, abiotic factors, like a chemical drift from a lawn spray, poor soil pH, or extreme weather, they tend to hit everything in an area uniformly. Think about it. If every single plant species in your garden bed looks sick all at once, it's almost certainly an abiotic environmental problem, not a contagious bug.
Now, what's really interesting about this slide is how it breaks down the timeline of the damage. Biotic, living issues slowly worsen. A fungal leaf spot, for instance, will progressively expand over days as the pathogen colonizes new tissue. Conversely, abiotic injuries have a very sudden onset. If a weird late frost hits your plants overnight, the damage appears suddenly the very next day, and then it simply stops progressing. It doesn't continuously spread to new growth.
Finally, Section 5, the usual suspects. It's time to narrow down the culprits. Okay, it is time to bring all of this evidence together. Check out this handy cheat sheet, directly inspired by the interior scape data. When you look at the usual suspects for common symptoms, it is almost entirely environmental. Wilting and dripping, that's usually just excessively dry soil or root rot from overwatering. Pale green leaves, often just a basic nutrient deficiency or really poor lighting. Sudden leaf drop, frequently caused by a sudden cold draft or transplant shock. What looks like a terrible, contagious disease is, more often than not, just bad horticultural care. So here is the absolute core takeaway for today. Always rule out abiotic, non-living causes first. Check your soil moisture, look at your lighting situation, analyze your recent weather, and review your fertilization history. You've got to eliminate these non-living environmental stressors before you assume you have a contagious outbreak. Not only are abiotic issues the most common culprits by far, but they're also much easier to correct. Plus, they don't require you to spend a fortune or spray a single drop of chemicals in your garden. Well, we've covered the crime scene, we've identified the victim, separated signs from symptoms, and tracked the timeline to find those usual suspects. You now have a solid forensic framework for your initial assessment. But remember, the plant world is absolutely full of masterful disguises and hidden microscopic wars. So the next time your plant looks sick, are you ready to investigate before you incriminate? Use these tools, save your plants, and stay curious. We'll see you in the next explainer.